Now that we've taken a look at piecewise functions and we've kind of had a basic introduction to them, you may be just a little bit confused as to what they really are and what they really look like still. So that for this particular example, we're actually going to graph a piecewise function, and this will give you a better sense of what they look like on an actual graph. And it'll give you the clear vision of why they're called piecewise functions, because you'll actually see the two pieces of the given function. So let me take you through a few steps here in example 2, on graphing this piecewise function. So you can see here that we have f of x equals these two parts of lines based off of the condition x is less than 1 and x is greater than 1. So what we're technically going to do, and everybody kind of has their own method about going and doing this, so if what I'm doing doesn't fit you perfectly, maybe discuss with your teacher an alternative method to actually graph these things. But what I tend to like to do is I like to graph both lines completely. And so I'm going to actually graph 1/2 x plus 3/2. And then I'm also going to completely graph negative x plus 3. Now, if you're doing this on the computer, the method that I'm suggesting can be a little bit difficult, because what I'm going to do is I'm going to actually graph the entire line, and then I'm going to erase the part that I don't want. Now, if you understand this process, you can totally bypass that step and just graph the piece that's easiest for you. But just kind of see me out and hear me out, and see if you can kind of connect with what the end objective is. So what we got going on here is I'm going to graph y equals 1/2 x plus 3/2. So 3/2 is, I'd say, part of the way up, 1.5 blocks up, and then I'm going to go up 1 and over 2. So I'm going to go up 1 over 2. That'd put me right there somewhere. I can go down 1, backwards 2. Excuse me. That's going to put me about right there. And I'm going to just use the little highlighter function here, so I could actually graph that line going all the way through just like that. Now, I'm just going to go ahead and move on to the other one as well, and then I'll come back to the piecewise part. So if I want to graph negative x plus 3, I'm actually going to go up 1, 2, 3, and I'm going to have a negative 1 over 1 slope. So I'm going to go down 1 over 1, down 1 over 1, and so forth. And then I could graph that. Now I'm just going to use this little highlighter tool. And so you can see here clearly that when I do that, I don't pass the vertical line test. I have these overlapping x values that are being repeated between the two lines, and so I really need to eliminate a piece of each of these graphs. Now, what we're going to do right here, this one right here, is really going to kind of create what we call a boundary line. So I'm actually going to just draw a little dotted line to represent a boundary at 1. So I know right there at that level that I need a piece on one side of that, and I need a piece on the other side of that. Okay, and so let's take a look at this. It says I'm going to graph 1/2 x plus 3/2 for all the x values that are smaller than 1, less than 1. And so all x values that are less than 1 are actually over here on this side of the graph. And so I need to graph the part of the line right there that is on this side of that line. And so I can kind of erase that highlighted part. Then I need to graph negative x plus 3 for all of the x values that are bigger than 1. That's everything on this side of the line. So I only really need to graph this part right here. And I can get rid of this highlighted part. As a result, what you see is we have one piece of the line on the right side of 1 and one piece of the line on the left side of 1. And oddly enough, they actually intersect right there on 1. So that's kind of a unique situation right there. Now, you can clearly see between the red and the blue graph that we have two pieces of two different functions, but this is considered one function together. Uh, so these two parts actually go together and they're called one piecewise function.